So this presentation is about third-party security patches and the hot patching techniques used to implement them. In the next hour, we'll talk about three specific areas. First, we'll do an overview of the recent developments in the third-party patches starting from December 2005. Then we'll talk about the implementation techniques. We'll briefly cover the Microsoft hot patching implementation. And finally, I'll talk about the vulnerability analysis techniques that I used to develop these hot patches. At the end of the presentation, there will be a demo where I will analyze a security vulnerability from scratch, and I will build a hot patch for it in about 15 minutes. So in this talk, when I say hot patching, I'm referring to a specific method for modifying the behavior of a program by modifying its binary code at runtime. That's not a new thing. It's been used for many years. Most debuggers use a hot patching technique to implement software breakpoints. It's also used for instrumentation, hooking API functions, cracking software, cheating at World of Warcraft, and most recently, deploying software updates, including fixes for security vulnerabilities. And this has been done by both vendors and by third parties. And this is what we're going to talk about today. In the last 8 months, I guess, we've seen three third-party security patches. The first one was the WMF patch written by Ilfak Gulfanov. Most of you probably know, but Ilfak is the author of IDA Pro, which is a widely used disassembler, fairly popular in the security community. This was the first patch that got a very wide deployment and generated a lot of buzz. So 3 months later, it was followed by two more developed independently by EI and Determina. This time they were for the Internet Explorer create text range vulnerability. So let's look at the vulnerabilities that these third-party patches fixed. The WMF vulnerability was interesting because it was found in the wild, and when it was first reported on the public security mailing lists, it was already being actively exploited and used for malware distribution. So it was fairly critical. Another thing that made it worse is the fact that the vulnerability was not a result of memory corruption, like most buffer overflows are, but instead it was a feature of the WMF file format. This feature allowed the attacker to put arbitrary code in the file that would get executed whenever the file was being displayed. And Internet Explorer could be used to display these files if they were hosted on a web page. So it took Microsoft 10 days to release a patch after the initial reports of the vulnerability. Ilfak Gulfanov released his on December 31st, beating Microsoft by about a week. His patch consisted of a small DLL that was loaded into all processes using the AppInit DLL's registry key. This little piece of code loaded GDI32, patched an exported function in it, and this function, the exported function that he patched, was responsible for handling the WMF records that contained the arbitrary code. So Ilfak's patch added an additional check that looked for that executable code and aborted the processing of the file if it was found. It's also interesting that when Microsoft released their patch, it was not exactly the same, but fairly close to Ilfak's. So this incident showed that it is indeed possible for a third party to patch a security vulnerability and get it mostly right. So 3 months later, we saw another security vulnerability affecting Internet Explorer, and that seemed suitable for hot patching. This time there were two security companies who decided to develop these patches. The vulnerability had been disclosed to Microsoft. It had been reported privately about 2 months before the patch came out, but about a month later it was disclosed publicly, and then we started seeing exploits for it. It turned out that the vulnerability is fairly easy to exploit, and the Metasploit project had a working exploit code for it a few days after the vulnerability disclosure. So again, we saw the two third-party patches being released about, I guess, 2 weeks before the Microsoft patch. The two patches were by EI and Determina. So let's take a look at what they did. The EI patch was slightly different than the ILFAC patch in its approach, because instead of modifying the application in memory, it created a copy of JScript DLL, and it patched it on disk. It used a pattern matching technique to find the instructions in the file that needed to be patched, and then appended a little bit of code to initialize an uninitialized variable, which was the cause of the vulnerability. It also modified the registry to force Internet Explorer to use the patched version of the file instead of the real one. The Determina patch, which I wrote, was closer to the ILFAX patch in its mode of operation. Again, it was a little DLL that was loaded into all running processes. It intercepted the loading of MS-HTML DLL where the vulnerability was, and patched a function in that file. Instead of using an exported function or pattern matching, I had a list of hard-coded patch points for about 98 different versions of MS-HTML, and these patch point locations were determined using an in-house tool we have and a big database of all Microsoft DLLs. On most versions of MS-HTML, it was sufficient to modify a single byte in the vulnerable function to fix the vulnerability. Instead of adding additional code to add a new check, I just redirected a conditional jump to go to a different place where the code already existed to fix the vulnerability. So, having looked at these third-party patches, the question arises of why should you use them? What are their advantages and disadvantages? Obviously, if the vendor patch is not available, then a third-party patch is a good alternative to protect yourself. In this, third-party patches are competing with other security systems, such as network-based intrusion protection systems and others. One advantage that the patches have is that they fix the vulnerability on a very low level, modifying the code exactly where the vulnerability happens. This makes them exploit independent, because unlike a lot of signature-based systems which rely on standard shellcode patterns or something like that, the third-party patches fix the actual vulnerability, so they don't really care about what kind of exploit is being used as long as it exploits that hole. This also makes them not vulnerable to evasion, which is fairly successful against network-based IPS systems, and I think HD had a talk about that at this conference. The disadvantage of the third-party patches is mostly related, the disadvantages are mostly related to the insufficient resources that the people producing them have. Obviously, a fairly small company like ours does not have the resources of Microsoft to do QA testing on the patches. Also, support for multiple OS versions and languages, different language packs, is also limited, again, because of limited resources. Another problem is that some of the vulnerabilities require very extensive changes to the application, including, like we've seen Microsoft patches where they completely redesigned a subsystem of the application to fix some sort of design vulnerability. So obviously, things like this will be very, very hard to hot patch, most likely impossible. So we're not going to see hot patches for every single vulnerability, just the ones that are more well suited to that technique. However, even given these limitations, I believe that third-party patches are a good option, especially for the cases where the risk of system compromise is great, but the risk of interoperability problems or the impact of the interoperability problems is not that big. I believe that most enterprises already do have a QA cycle for the official patches, so maybe a similar QA cycle can be used for the third-party patches as well, remediating some of the QA problems. Another question that often comes up is about the issue of trust. I get this especially from the press. They ask, why should we trust this company with patching our system? Well, you have to realize that most commercial software which you run on your system is, especially security software, is pretty intrusive and might do things that are even more dangerous than the third-party patches. In fact, all three of the patches that I talked about were very, very small, very self-contained, and they also included source code which could be reviewed to make sure that the patch really does what it intends to. I think the small size combined with the availability of the source code makes it much easier to verify that the patches are actually good and trustworthy as compared, for example, to a large closed source application. So now we're going to move on to how to implement these hot patching systems. The simplest form of hot patching is to just modify the code in place. You can use this to remove code from the application by overriding its instructions with no-op instructions. You can also use it to replace some instructions with others. One limitation here is that the instructions have to be, you're limited in size. The instructions have to be of the same size or possibly smaller. You cannot add new code to the application. And the classic example for changing an instruction is if you have a program with a license check, and after the call to the function that checks the license, you have a conditional jump that lets the program continue, or it aborts it. If you replace that with its opposite conditional jump, then the program will work when the license is invalid instead of the other way around as it was designed. If we want to add code to an application, we need to use a different technique, and the one most often used is the 5-byte jump override. This is very common for hooking API functions. In this case, in this example, we have a function, and we see the standard function prolog in the beginning, and then we override the first 5 bytes of the function prolog with a jump instruction that goes to our hook. This means that whenever somebody calls the function, our hook routine will be executed, and we get to do whatever we want it to. Most often, after we execute our hook routine, we want to return back to the original function and continue its execution. Maybe we've done some logging, maybe we've modified some of the parameters, but we still want to go back to the original function. To do this, we need to save the instructions in the first 5 bytes, the instructions that we overrode. So we make a temporary copy of those instructions, and after the hook routine does its task, we need to execute the saved instructions and then jump back to the remainder of the patched function. And this will make sure that the stack frame of the patched function is established correctly, and it should work as if nothing had happened. There's some limitations when you do a 5-byte jump override. There are some limitations to the patch to the locations that you are allowed to patch.